The root locus is a graphical representation of poles and zeros or transfer function. It shows how the roots of characteristics equation change as the parameter of the system is varied. The rules of root locus are a set of guidelines used to sketch the root locus of a control system. And what the rule number 1 states is that the number of branches in the root locus is equal to the number of poles of an open loop transfer function. We can also say that the roots of the equation can be real or complex or a combination of both. The root locus is generally symmetrical about the real axis. Thus, the plot needs to be symmetrical about the real axis of S-plane.
With this, we are going to solve an example. The question states obtain root locus plot for the unity feedback system with transfer function g of s equals to k by s plus s times s plus 2. Now for the poles we have 0 and minus 2, and for the zeros we have 0. So from this we can see that we have two number of poles and 0 zeros. Now to calculate the number of asymptotes, it's p minus z, which is 2 minus 0 equals to 2. The angle of asymptotes is theta is equals to 2x plus 1 by p minus z times 180. Now in this, since the number of asymptotes is 2, so x would be 0 and 1. So substituting this, 2 times 0 plus 1 by 2 times 180 is 90, and 2 times 1 plus 1 by p minus z times 180 is 270. Now to calculate the centroid of asymptotes, it's real poles, summation of real poles minus summation of real zeros by p minus z. Now for the summation of real poles, it is 0 plus negative 2, so, and for the real zeros it's 0, so negative 2 minus 0 by 2 is minus 1. Now to calculate the breakaway point, first we need to configure a character equation, that is 1 plus gs times h of s equals to 0. Now gs times h of s is nothing but k by s times s plus 2. So 1 plus k by s times s plus 2 equals to 0. Now resolving the equation, we get s square plus 2s plus k equals to 0. Now making k the center of equation, k equals to minus s square minus 2s. Now differentiating this equation, we get dk by ds equals to minus 2s minus 2 equals to 0. Now making s the, to find what s is, s equals to minus 1. Now calculating the intersection of the imaginary axis, the character equation s square plus 2s plus k equals to 0. Now using this we can find the route array, and then s square, s1, s0, 1, 0, 2 and k. So now using the route theory, we multiply 2 times k minus 1 times 0 divided by 2, which would be k. Now this k should be greater than 0 and is not marginally stable. Now using these points we can plot the graph. So I have already plotted the graph, but I'll go along with you. So from the poles we know that s is 0 and s is minus 2. And then for the centroid of asymptotes, we know that it is at minus 1 and the breakaway point is also at minus 1. Now from that, when we calculated the angle of asymptotes, it said it is 90 degree and 270. So from the centroid of asymptote, we extend a line that is up towards the 90 degrees and down towards the 270 degree. Now if we are to divide the real axis, we can see that the positive imaginary axis is just a mirror reflection of the negative imaginary axis. So from this we can see that the rule 1 is satisfied, which says that the real axis should be symmetric. Thank you.
So we can see that the root locus is symmetrical about the real axis because the roots of the characteristics equation comes in complex conjugate pair. And that's a brief explanation of the root locus and its symmetry. Thank you for watching.